anion will be greater than the parent atom. Okay. Electropositive elements, the elements which have tendency to donate electron, they can only form positively charged ion. They are called electropositive elements. Okay. And electronegative elements, the elements which have tendency to accept electrons and in their valence shell and to become anion or negatively charged ion, they are called electronegative elements. So we have here chlorine, bromine, fluorine, all are electronegative elements. Okay. By gain of electron, by gain of one electron, it can become an ion. It can become an ion. Okay. Okay. Now this is called electropositive. Electropositive is Na. Na becomes Na plus like this. Okay. Then we can see here electrovalent bond or ionic bond. How it forms? Chemical bond formed between two different atoms by the transfer of one or more electron. Now we will see here sodium has outermost configuration 2, 8, 1 and chlorine has outermost configuration 2, 8, 7. So now sodium will give one electron to chlorine. So loss of electron happens from sodium. That is why sodium becomes Na plus by taking this 2, 8, 8. Okay. Sorry. And chlorine becomes Cl minus. Okay. So 2, 8, 8 like this. Now we are seeing here the next situation. Okay. The next situation, this Na plus and Cl minus will combine to give NaCl. This is the bond form is called ionic bond between them. How ionic bond form? By transfer of electron. Okay. So loss of electron from sodium, gain of electron to chlorine, and both are forming positive and negative ion. Okay. So here the transfer of one or more electron from the valence shell of electropositive to the valence shell of non-metallic is called electrovalent atom. Okay. Now electrovalency, the number of electron which an atom of an element donates or accepts in its valence shell so as to have a stable configuration like that of nearest noble gas is called electrovalency. Like for example, in case of Na, how much electron change? Loss of one electron. Okay. Loss of one electron here, and here Cl to Cl minus, gain of one electron. Okay. So in both the cases electrovalency will be 1. Okay. Now we are seeing the next electropositive valency. The number of electrons in an atom of an element donates from its valence shell to get a stable configuration. So Na is donating one electron to get Na plus. So electropositive valency for Na becomes 1. Okay, here. Then same way electronegative valency, the number of electrons by an atom non-metal accepts its valency shell so as to have a stable configuration like a noble gas, that is called electronegative. So chlorine has taken one electron, so electronegative valency is also 1. Okay. Now electrovalent compound or ionic compound, the chemical compound formed as a result of transfer of electron. We have seen just now sodium is losing electron, chlorine is accepting electron. This is called transfer of electron from the valence shell of an element to the valence shell of another element. It is called electrovalent compound or ionic compound. So here there is ionic compound is obtained. Sodium chloride is ionic compound. Okay. Now we are seeing properties of ionic compound. They are generally hard, crystalline, solid. Table salt you are using every day at home, so you can visualize, you can imagine how it is. They are hard, they are crystalline solids. Then they are generally non-volatile, means it doesn't evaporate by itself, and hence high melting point, boiling point. It does not melt also easily. Then they are good conductor of electricity in the fused state. So in the molten state or the solution form, they are good conductor of electricity. They are generally soluble in water. Table salt is soluble in water, and aqueous solutions are good conductor of electricity. Why? Because aqueous form NaCl will break as Na plus and Cl minus. So free ions will provide passage for electric current. So they are good conductor of electricity. The chemical reaction between aqueous solution of ionic compounds is very fast. Okay. So next we are talking here, till now we have discussed about the ionic compounds. Okay, now let us discuss about metallurgy. What is metallurgy? Under the earth crust we are getting ores and minerals, that is in the combined state. Combined state means like for example, if you have zinc, so zinc is not in the form of zinc. Zinc can be in the form of sulfide, zinc carbonate, zinc sulfate. So all other components are combined with that. Now you wanted zinc for particular purpose or iron for particular purpose, so you have to purify it. You have to separate that combined state from that and purify it, remove the impurities. That is only called metallurgy. Metallurgy is getting metal economically and conveniently. Okay, so various process in the extraction of metal from its ore, then refining, including study of its properties and uses, is only called metallurgical extractions. Now in metallurgy we will see the impurities are removed. Now that impurities are called gangue or matrix. Okay, unwanted impurities. What are these? These are unwanted impurities such as sand, stone, mud, limestone, mica. Under the earth crust, when it has come out, everything has come out with that, so associated with the naturally occurring ore. Okay, then dressing of ore. What is dressing of ore? Involves processes such as hand picking. So now sometimes impurities you can just pick by hand. The bigger objects like big stone pieces are there or big dirty pieces are there, we can remove it. That is called hand picking. Grinding, crushing and pulverizing. Pulverizing means if it is very big pieces, then also separation is difficult, so you have to chop it to the smaller sizes. That is called pulverizing. Okay, or grinding or crushing. Then when it is in the form of little lesser quantity, smaller size, then you can purify it. Okay, using that. Then we'll give an ore such a physical form so that gangue can be easily removed from the ore. Otherwise very big object, if we take stone form of object, we cannot remove the impurities. Now what is concentration? Concentration means removal of maximum possible impurities and getting the ore possible, maximum metal possible. So which helps in the removal of gangue from the dressed ore, thereby increasing the concentration of the metal in the ore. Okay, now there are different kind of concentration methods. One is magnetic separation. Magnetic separation means sometimes what happens, the magnetic impurities are present. How to remove it? So there are this kind of apparatus will be there. There will be two rollers. One is magnetic roller, one is non-magnetic roller, and one conveyor belt will be there. Okay, so from here the charge, the raw material will be put and the belt will be starting. So what will happen? The particles which are magnetic in nature will get attracted towards the magnet and form a heap close to magnetic roller, and particles which are non-magnetic, which gets repelled and forming a separate heap away from the magnet, like this. So this is called magnetic separation. So it's the concentration process followed by dressed ore. If there is ore is magnetic in nature and ore contains magnetic impurities, such in this is the ore which has impurities like hematite. Hematite ore is the magnetic separation can be done. Now gravity separation or hydraulic washing, this will be done generally with sulfide ores. This will be done generally with the concentration. Here the size difference should be there. Ore and impurity, one should be bigger in size, gravity should be more, density should be more, and another one should be having density less. So according to gravity, the heavier objects will go down and the lighter objects will be on top. Okay, so which have metallic ores of high density as compared to density of gangue, it is not followed in the case of sulfide ores. Now sulfide ores can be purified by froth flotation specifically. Okay, so here what is happening, we are taking a big tank. In that tank there will be water with pine oil and the ore mixture will be there, and it will be skimmed. There will be one skimmer and the hot air will be passed here. There will be small holes. So when skimming action will be done, what will happen, the ore will be, sulfide ore will be converted into froth. Froth means it is like a fog. So that froth will start floating on the top because it is lightweight. It can be separated. So like that, impurities will settle down at the bottom due to high density, and froth can be separated. This is only called froth flotation. So froth will float on the top. That's what it is called, froth flotation. It is specifically for sulfide ores, zinc sulfide, lead sulfide, copper sulfide, copper pyrites, all this. Okay, then in this process, the sulfide ore is immersed in a mixture of pine oil and water and then strongly agitated with the compressed air. Okay, the sulfide ore rises up along with the froth produced by the oil, but the gangue sinks at the bottom. You can see here, there will be a gangue. Gangue will be sinking at the bottom. Okay. Next we are seeing chemical method for concentration, followed by such ore, source of aluminium, in which this method is having another name called leaching, okay, in which density of ore and the gangue is almost same. So here the ore will be treated with sodium hydroxide, it converts to sodium aluminate, and like that it will be separation from the impurities. Now calcination and roasting, there are two methods. So calcination is specially opted for the carbonate ores, where the ore is heated in absence of oxygen, okay, and strongly heated below its melting point. So what will happen, the ore becomes converting into its oxide, and carbon dioxide gas is released as a side we can say side reaction, or the impurity which is coming out, okay. And now here mass becomes porous. So let us see here the process of heating the ore in the absence of air. You remember this very carefully, absence of air below its melting point. Why? Because our objective is not to melt, our objective is to remove the impurities such that it decomposes to give metallic oxides. So what are the things happens? Moisture will be removed, or mass becomes porous, volatile impurities like carbon dioxide is a volatile gas which will be evaporating, decomposes carbonate ore to oxide ore, okay. So zinc carbonate will convert to zinc oxide, like this. Roasting is the process of heating the ore in excess of oxygen, again below its melting point. Again ore will be converting to its oxide, and sulfur dioxide will be removed as a impurity, okay, such that it changes to oxide ore. What are the things happens? Remove moisture, mass becomes porous, expel the volatile impurities like sulfur dioxide, okay, and oxide sulfide ores to converts to oxide ore, zinc oxide it is converting. Now after this melting will be done, the oxide ores will be converting to its using the suitable reducing agent, okay, suitable reducing agent, the oxide ores will be converting to its metal, okay. And you can see the suitable reducing agent will be carbon or the form of carbon. Coke is also form of carbon. The reducing agent commonly used are coke, carbon dioxide, carbon monoxide, hydrogen. For reducing highly active metals like electrolytic reduction is also employed, okay. Now what is refining? Refining means till now we try to remove the impurities as much as possible, but still to get 95 to 98% purity, refining is commercially most acceptable method. So refining of metal is done by number of methods. However, the best method is electrolytic method here, okay. So in this method the pure metal is made cathode, here the pure metal is made cathode and impure metal is made anode, okay. So pure metal is cathode and impure metal made anode. The cathode and anode are immersed in the aqueous solution of that metal salt only, okay. And then what will happen on the passage for electric current, the like for example if we are doing copper, so the pure copper will be electrode, and impure copper also will be electrode. Copper sulfate solution electrolyte, it will be dipped. When the circuit is completed, electricity is passed, what will happen? On the passage of electric current, the pure metal from the anode is transferred to the cathode, okay. And like this the impurities will start coming down and the pure metal will start depositing on the another. So we will get pure metal in that at the end that electrode will be taken out and pure metal will be obtained. The thermite mixture consists of 3 parts of ferric oxide and 1 part of powdered aluminium, okay. It is commonly employed in spot welding such as broken railway lines and all can be done. Now what is alloy? Alloy is a homogeneous mixture. Homogeneous means uniformly mixed together. 2 or more metals obtained by melting them together, okay. Next we are seeing major alloys of aluminium like duralumin or dural. Here aluminium 95% maximum aluminium, then copper 4%, manganese 0.5%, magnesium 5%, and magnesium again 95% aluminium and magnesium 5%, okay. Then the major alloys of iron ore, again iron maximum percent, that is 73 to 80%, and carbon 1%, chromium 18% and nickel 1%, okay. Manganese steel, again iron 83 to 84%, manganese 15%, carbon 1% to 1.5%, okay. Tungsten steel, again it is ore of iron, 79 to 85% of iron, tungsten 10% to 20%, carbon is 1%, okay. And alnico, here iron is 60%, aluminium is 12%, nickel is 20% and cobalt is 5%. That's what it is called alnico, because aluminium, nickel and cobalt is present here, okay. except iron. Now major alloys of copper, aluminium, bronze. So copper will be 90% and aluminium will be 10%. Brass, which is used for most of the idols making and all, that is copper will be 60 to 80%, zinc is 20 to 40%. Then bronze, it is copper will be 80%, zinc 10% and tin 10% also. Okay, then gunmetal, which is copper is 88%, tin is 10%, zinc is 1 to 2%, and German silver, copper is 30 to 60%, zinc is 25 to 35, and nickel is 15-35%. Okay, now gold is also alloyed. Generally pure gold will not be taken for making jewelry. Why? Because it is very soft metal, so the molding in a particular shape, and after that the life will be very limited. That is why it is always mixed with copper. So gold is alloyed with metal like copper, silver, cadmium, so it gives hardness and workable at low temperature. Okay, so purity of gold is measured in carats. 100% pure gold is 24 carat. Okay, so 24 1 carat will be 4.1666 gram per 100 gram of alloy. Okay, so corrosion. What is corrosion? The formation of layers of undesirable compound on the surface of metal due to action of moist air containing impurities like iron. Iron undergoes rusting in presence of moist air or water, that is only called corrosion of metals. Okay, so corrosion of metal takes place only if the surface of the metal comes in direct contact with moist air to prolonged time. So there are different examples of corrosion. One is rusting of iron, one is tarnishing of silver. Silver articles you would have seen turns black. Okay, and then copper corrosion. Copper also develop a green color copper coating, that is called basic copper carbonate. Okay, then surface of metal comes in direct contact with moisture, and then rusting, the slow conversion of metal iron into hydrated ferric oxide in presence of moist air is called rusting. Okay, rust is a flaky non-sticky brown powder formed on the surface which will disintegrate the iron, and the strength of iron is getting reduced because of rusting when the iron is exposed to moist air. Now factors which promotes rusting, which are the factors which can increase the rusting? One is moist air, then the presence of salt like sea water or the salty water will always increase this, then presence of more active metals than iron in presence of pollutants such as nitrogen oxides, sulfur oxides, carbon oxides in air, which can promote rusting. Okay, rusting, how it can be prevented? It can be prevented by the coating the surface with red lead, paints, enamel, oil, grease, plastic coating or galvanizing. Okay, and tinning, electroplating with nickel or chromium, converting iron into stainless steel, like that is alloying. So this all the methods can prevent the rusting of iron. Okay, thank you.